In this video clip, we are looking at the different classes of hormones, basically comparing their molecular structure. Their molecular structure is going to have a huge impact on exactly how the hormone is going to act when it gets to its target cell. Is it going to be able to slip through the cell membrane, or does it have to depend on a receptor on the outside surface of the cell? We divide these into two main groups. The water-soluble hormones are the ones that have to use an extracellular receptor because they cannot slip through that phospholipid bilayer of the cell membrane. The second group are lipid-soluble hormones, and they can very easily go through. Okay, first of all, in the water-soluble hormones, we have amino acid derivatives. These hormones use one of two amino acids. The amino acid tyrosine is used for making thyroid hormone. When you look closely at the thyroid hormone, if you looked at its molecular structure real deeply, you would see tyrosine with 4 or 3 iodine atoms attached to it. The second amino acid that is used for hormones is tryptophan. A source of tryptophan is turkey, and tryptophan has been implicated in feeling really tired after Thanksgiving dinner. Some people say that, well, no, that's really not the case. It isn't the tryptophan at all, but rather that you ate too much food. Well, maybe either way is correct. Nonetheless, tryptophan is used to make catecholamines. Catecholamines include epinephrine, norepinephrine, and dopamine. Those might be vaguely familiar because you may have heard of them in the nervous system. They are neurotransmitters. They play a dual role as both a neurotransmitter and a hormone. We're not going to talk a lot about them right now. Instead, I want to also identify that tryptophan is used in melatonin. And if you recall, melatonin is the hormone that is going to control your sleep cycles. Also in the water-soluble hormones are peptide hormones. In this group we have glycoproteins. These glycoproteins are fairly long. They have more than 200 amino acids, and in addition they have a carbohydrate side chain. Included in these glycoproteins are the hormones thyroid stimulating hormone, luteinizing hormone, and follicle stimulating hormone, all three of them coming from the anterior lobe of the pituitary, but others coming from other organs as well. The short polypeptides are considerably shorter in length, hence their name, short polypeptides. And in this group also we find small proteins, those that are going to be less than 200 amino acids long. Included here we have ADH and oxytocin, each of which are, oh yay, a grand total of 9 amino acids long. Then we get to the small proteins like insulin, a whole 51 amino acids, growth hormone, 191, and prolactin, which is 198 amino acids long. Compare that with the lipid-soluble hormones. This time we are deriving most of our hormones from cholesterol. At any rate, it's going to be a lipid base. In this group are the eicosanoids. I'm going to switch and start here with the eicosanoids instead of the steroids. The eicosanoids include leukotrienes, which are involved in the immune system, thromboxanes, which are involved in blood clotting, Most of these compounds in this group are involved with the lymphatic and the cardiovascular system, and so we'll spend a lot of time talking about them there, not so much in the endocrine system. Lastly, we have the steroid hormones. This is pretty much the molecular structure of cholesterol, so you can see its base there in that estrogen molecule. Other hormones that are steroid based are progesterone, testosterone, and then we have a number that come from the adrenal glands like the corticosteroids and so on. Steroids are probably most familiar to us in the idea that they are given as an anti-inflammatory drug to treat injuries, pain, that kind of condition. Unfortunately, steroids are also implicated in huge weight gains when they are used in that manner.